Vaibhav, you can hear me fine, right?
Yeah, you're audible.
All right, cool.
Guys, am I audible also?
Yeah, yes, you.
Yes.
I think Vishal has raised his hand.
Okay.
Something just wrong.
We'll just wait for another 2 minutes to start. Yes, is my screen visible? You're on mute.
Yeah,
Yeah,
Shubham. That's
All
correct.
right. So we'll get started.
Yeah, sure.
yeah, sure we can.
All right. Thanks. First of all, thank you everyone for joining this webinar. It's quite late, so really grateful for you to to have you guys here with us. So basically, today we are going to talk about how we are building Matters.ai, and how, especially how we're building it in a way that it can run on our customer's data center. So before I start, I would like to introduce all of us. So I am Shubham. I work with the platform team. Mostly I look at integrations. So our integration with AWS, GCP. We have Yashraj. Yashraj has been with us for about a year. He mostly works with the ML team, and he mostly takes care of the data classification that happens in the ML side of work. And then we have Vaibhav, who is predominantly working on real-time alerts and DDR. So that is us. And then I just like to set some context. What is DSPM and DDR? So DSPM and DDR are two of the fundamental offerings of Matter.ai. So DSPM stands for Data Security Posture Management, and DDR stands for Data Detection and Response. Now, DSPM solutions are basically solutions that in your infrastructure tell you where your sensitive data lies at rest. Let me clear it up with an example. So, say you're an organization who is on AWS. Now, you would have engineering teams who would be creating their own S3 buckets, RDS instances. But as a security team, you wouldn't really know where the PHI data or the PII data or the sensitive data resides. So a DSPM solution basically tells you, ki, okay, these are your infrastructure elements, and this is where your sensitive data lies. DDR is more inclined towards events. So all these cloud providers and the SaaS that we work with, say O365 or Google Workspace, emit out events as activities happen on their platform. So in case of AWS, we have CloudTrail, which basically gives you a log of all the events that all your AWS users or the services that you're using, what is happening on that service, who's performing that action, anything to do with IAM. So you get all those logs as part of CloudTrail logs, and then we have other platforms like if you're using databases, the databases have their own logs, and SaaS also provides you certain types of event logs that will tell you ki, okay, a file was created on Google Workspace or a file was shared with a certain user. So any software that works on that domain and gives you sort of like a security analysis falls under the purview of DDR. Now, for DSPM and DDR, we have four major components. So first is data inventory. So like I already told, data inventory is basically a collection of all the assets that you have. So an S3 would be part of your data inventory, and RDS would be part of your data inventory. All these individual S3 buckets and RDS instances would collate and form your data inventory. Access graph is basically uh, a, a, a overview of who has access to what. Now, say if you have an S3 bucket, a lot of IAM users can have access to that S3 bucket, right? Or a lot of roles can have access to that S3 bucket. If it's a SQL database, be it MySQL, Postgres, you would have SQL users who would have access to that database. They could be a service user, they could be a normal user or a DBA. If it's an SMB share which is on-prem, then your user would become your Windows user, like Windows NT users who would log into the Windows SMB share and then get access to the share. Alerts and exposures are basically uh, surfaced based on the rule set that you have. Now, we would like all these products would have would come with a predefined rule set, but then these are also customized as per the organization's requirement, wherein an org can define certain alerts and exposures that might surface when certain events come out. And DDR and DAM, like we have already spoken about, are basically for more on the real time monitoring and the real time alerting. So this is basically an overview of DSPM and DDR. I'd move on to the next slide. So at Matters.AI, we are basically, like I already mentioned, DSPM and DDR are one of the core foundational offering of what we are building. Now, when we are building this, there is a prerequisite that if, say, a customer wants to know where the sensitive data resides, right? Uh, they would want this operation or this entire analysis to happen on their premises. So when we are working with a customer, all our workload needs to run on their infra. The and when we are building Matters, the problem is that given these services that we are building needs to get deployed to customers' infra, customer would have different sorts of infra. So some customers are on AWS, some customers are on GKE, some customers are on-prem. So when we are building this or enabling our engineering teams to build these services, we have to make sure that whatever they build runs identically on all of these infrastructure that our customer has. I'll move on to the next slide. So this slide basically talks about the primary prerequisite that any security tool must have. So one is residency, wherein anything that happens should happen on the customer premises. Data should not be moving out of the customer premises because that's a violation of compliance. If data is moving, it should be encrypted. If we are catering to multiple tenants, if you're building out a solution, then there should be a proper tenant separation wherein data of different customers should not get mixed up on a single database, and then processing and everything needs to happen on their own isolated environments. Um, Independence is key. If, say, we are deploying certain services, they should be functional in case something goes wrong on our control plane, and vice versa. there should be least privilege. So our tools basically do classification, right? So it needs to have access to your data. Now, any tool that works in this purview needs to follow the principle of least privilege. That is, it should only have read permissions. And then when it comes to delivery, you should be able to deliver OTA updates or any enhancements that we are building out onto our services to be rolled out seamlessly. Um, Over to you, Yash. You can take it from here.
Oh, thanks, Shubham. So hello, guys. So from now, we will be talking about how Matters.AI, the platform, is deployed in the customer's environment that Shubham has just talked about. So as the context was laid out, so the environment that we get is never in our control, right? So ideally, when you would build systems, you would build it in a certain way and would ask your DevOps to get the ideal infra for it, right? But that's not the case with us. For example, you would want to have your services on, let's say, AWS, but what if the client is running on OCI, right? So that's not in our control. And for that purpose, we have gone with a Kubernetes first approach, which basically decouples us from the cloud provider and gives us an cloud agnostic platform to run our platform there, right? So and even if the customer is on premises, for example, a bare machine, a single VM that we get from the customers. So what we do, we install, so we provision a Kubernetes cluster using K3s there, and after that, everything is again agnostic to the platform that is running, right? Similarly, another constraint that we get is that, for example, in highly regulated customers, such as BFSI, we have a very air-gapped setup wherein customers generally do not allow us to have an inbound connectivity to install our products or systems softwares there, right? So we have developed a unique approach for it. So we created a bundle wherein we bundle everything from setting up Kubernetes to the last package that gets delivered onto the data plane, right? So we bundle it and we share it using the customer's preferred channel or pipeline, and then that gets deployed into their infra, right? And for the DAM agent, for the database activity monitoring, so we have a very lightweight software that runs on a very small machine right beside to the database, and it always acts post execution, and it never affects the real-time performance of the database. On to the next slide. Okay, so now we will talk about how we perform the DSPM at Matters.ai, right? So, basically, it involves multiple stages. So I'll walk you through each one of them. Starting with the first stage is discovery, right? So before we scan any data, we first have to discover what data we have to scan, right? And there is a certain hierarchy or a class in which we have classified data, right? What we term it as containers and data objects, right? So for example, for different kinds of integrations, let's say it's an AWS S3, right? So S3 would be a container, and all the objects that are stored in that S3 would be data objects for us, right? Similarly, for a database, the database instance would be a container, and all the database and tables inside it would be data objects, right? And while doing discovery, so there are multiple challenges. For example, if it's a cloud and SaaS, right? So these offerings often provide us with their public APIs, right? That makes it easy for us to discover data. right? But for systems which are on-prem, for example, an SMB or a self-hosted database, we do not get a public connectivity for it. So what we have to do is we have to discover that data on-prem and send that metadata back to our control plane so that we can apply our intelligent sampling that comes in this stage too. And one thing to note here is while doing discovery, we also create a static posture of the data. For example, the axis graph that Shubham already talked about, which basically tells us the posture of the data at rest, right? Now coming to the next stage, which is sampling, right? So now that we have all the metadata of the data discovered, right? So what here we do is we apply intelligent sampling, right? And this sampling depends on various factors. For example, it could be on the volume of the data, right? And it is definitely on the type of the data that we are scanning. So just to give you some context, for example, we are scanning a database, right? And enterprise customers have billions of rows in databases, right? And scanning each single row is not practically a good approach even. So for example, let's say a database has a column Aadhaar number or Aadhaar card, right? And the same and Aadhaar cards are being repeated for the 2 billion rows in that database, right? So let's say even if we sample 1,000 or 10,000 rows from that database, and we see that okay, this column contains a primitive type of data, and it always follows a certain pattern or a certain aligned to a certain data element. So we can confidently say that this column of this database will always have a Aadhaar number, right? So these are some few examples of the intelligence that we add to our or to our classification pipeline, and that is one of the reasons that we have coined a term DSI, that is data security intelligence, that we call it here at Matters, right? And the same intelligence is applied on the stage 3 of the pipeline, that is classification. Now that we have sampled the data that we have to scan, right? It comes the scanning part, and the major challenge that the scan has to run on the customer's infra, right? And that infra can be varied. It could be a large cluster of nodes that the customer might provide us on AWS, or it could be a single VM, right? And our workloads have to run basis on the provisioning that we have got, right? And the classification that we have done that we do is not a decade old regex based classification. We apply ML inference to the classification. We get the spatial context. We get the domain context and all of this, and combine it to basically detect a sensitive data from it. And the way we have built this pipeline is that this adapts to the customer's needs, right? So for example, a customer could be in healthcare, and a retina scan could be a sensitive data for them. And similarly, a customer could be in an aerospace industry, and airplane schematics could be a sensitive for them, right? So
Right.
adding those sensitive elements should not take a manual regression of weeks to ship it, right? So we have built the pipeline in a way that customers can manually create their sense of sensitive data on the Matters dashboard, and the pipeline automatically caters to that, and it keeps on evolving basis the feedback loop as more and more data it scans, right? Next comes the cataloging. So now that we have classified the data, the Matters AI intelligently builds a sensitive data catalog on that classified data. So what I mean by that is that, for example, let's say we have a PDF which contains a phone number, name, address, or mobile number, right? So we can say that this document would be a KYC document, right? So this is a document level cataloging, right? But let's say when it comes to a database, so in case of a database, you might want to get this labeling or catalog at the column level. What this column would mean, what this column would depict, what sensitive data is present in this column or in this table, right? So whenever someone is using the Matters dashboard, so they can have this catalog from the container to the column level, so basically providing all the sensitive data granularity that they might need. And the last stage is basically findings. So whenever we have discovered the sensitivity and of the data present with the customer, and we then correlate these findings with the posture that we built in the stage one, that is discovery, and then we surface the data, sensitive data exposure to the customers that are using our dashboard. So for example, let's say an S3 bucket is public, that we discovered it in stage one, right? And that S3 bucket happens to have sensitive data. And so that means that customer sensitive data is now publicly exposed, and that is a very critical exposure, right? So basis on all these intelligent correlations, we provide a posture and risk score for customers to have an idea of how to prioritize their remediation actions going forward. Okay, Shubham,
Very well explained, Yash. Yeah.
Okay, so next comes something that we all have been reiterating since the beginning, is how we adhere to the boundary that we draw, right? So we always say that we never let the customer's raw data leave their environment, and we stand by it. So for example, whenever we are classifying the raw data, right? So that raw data is always pulled in the same network as the customers, kept it on the disk temporarily. We scan it, and then that file is automatically cleaned, right? It never leaves beyond a certain threshold, and it certainly never leaves the environment, right? And for the few things that do leave the environment, and that specifically to our control plane, are the metadata of the results that give us an insight on how to what are the next remediation steps should be, right? And there are certain things that we might need to do all this. For example, database credentials to access the data present in the database, or access the activity logs that are happening in the database. So for that, we would need DB user and credentials, right? Now, if we had to store those DB credentials on our side, so that would be the customers would be very uncomfortable with this kind of setup, right? So we have built a secret service that goes into the data plane that sits on the customer's infra, and every credential that customers share with us always reside on their infra only, and we only take a reference of it, perform our action, and then the application never reads it again. And coming to one of the things that has been very red hot is endpoint classification. So that is something that we have pioneered very recently, and the beautiful part of it is that the data, depending upon the customer's choice, can be scanned either on their on the data plane that has been procured, or on the device locally itself, right? So the customer always has the control over the over how the data would be processed by us. So now we have talked a lot about how we manage the data at rest. So I will be handing over to Vaibhav to give some insights on how we do real-time data detection and response. So over to you, Vaibhav.
Yeah, thank you so much, Yash and Shubham, for explaining this well and setting up the context, as well as about letting the people know about the platform that we have. So I'll take it from here. So yeah. So basically, till now we have talked about the data at rest, right? As mentioned. But what if we are talking about the moving data? Or let's suppose someone is performing some events that they are not supposed to. And if they are doing it, how are we supposed to stop it or flag it? That's what this is all about. So we will talk about the DDR pipeline from here. So I'll also set some context on that. Like detection always here watches four kinds of activity, that is cloud audit trails, collaboration suites, managed databases, and the databases in your own stacks. So our pipeline reads all four, but tonight we will just go deep into the last one because it's the deepest lane, not because it's all do we have. So what we do exactly is, first of all, whatever the sources do we have, we do the collection of events through those sources. It can be any source as mentioned below, Microsoft 365, GWS, AWS CloudTrail, anything. And it comes down to the self-hosted Oracle, on-prem Oracle as well, and MS SQL as well. Now what we do, we have the collection of the events, but then we have to normalize them. Because if we don't normalize them, then we have to do the expensive work later. That is not being done by all other engines because we are getting the logs from different types of sources. So we do normalize all of that, basically saying who from where on what object doing what. Okay, then what we do, we enrich that as well. Basically, whatever the data we have regarding the events that were performed similar to the events that we are receiving right now, we do enrich it through our historical pipeline, that historical data that we do have using the pipeline. Then we decide, we match it against the rules. These rules are predefined by us and are editable and can be like more rules can be added by you as well. So then we decide on what we have to flag and raise the alert. Then we deliver the alert with context. It's not like only the alert and event that this happened. It contains exactly what happened, who did it, where it got executed, and what happened. Now we can go to the next slide. Yeah. So now basically we will talk about the self-hosted part here. Okay, because that is what the hottest development going on here, and that is what the deepest lane, as I mentioned. So we are not intentionally doing inline proxy currently. This is intentional because in inline proxy, everything you are sending is going through it. And if the proxy is out, then database outage will be there. So what we do, we sit beside the database, not between anything. We read the trail the database already writes. So we cannot slow a query down and we cannot block it, obviously. That is the position we chose, not the feature we lack here. Okay. So these are the things that we guarantee that okay, we are having the least privilege of the read only and audit of the audit view. We don't have any code on the database host. If any midstream activity is killed in between, then also we don't lose any event. We do promise, you can say at least once delivery, and collection continues even when the control plane is down. Let's suppose if it is down sometime, then the collection will be continued, and when it is up again, you will get the events back. So here there is no loss that is possible, that we guarantee here. And it's like one source per open pluggable database. And for every type of source, we do provide some sort of databases here. So let me just show you the cost of that, then tell you there isn't one on the side of the inline proxy that I told. One more thing I would like to flag here is about the part that is in the red, that we are doing the auditing from our side. We are only having the least only privilege as mentioned, and we ask the DBA to provide us the frequency on which they want to get the polling done. This is because if the volume is too high, then we don't want any network cost to be added. So it is based on the volume as well. And so that also guarantees that we don't have any write privileges. So if any cleanup has to be done, that would be done by the DBA itself, not the agent, because that is what we guarantee here. So we can go to the next slide. So this is what we have measured. Okay, so this was the numbers without a method. Basically, they were worth nothing. So it was a clean room on June this year. We ran some POCs on Oracle 19C Enterprise on 4 virtual cores. So database resets between every time. And we had some acceptance rules. So based on that, we came across with these numbers like the CPU per audited statement that we have got is 0.12 ms, and the amount of memory it needed was 256 MB, and whatever the events were polled were delivered to our side. Okay. And also, like again, this comes that the polling frequency is like, what do you say, changeable. Basically, let's suppose you are polling for the first time, you are getting 599 events, and then you are polling again, you are getting 0 events, then you are getting 1 event. So it depends on the volume of the database. We let the DBA decide on the frequency of the polling. Yeah, we can go to the next slide, Shubham. Yes, so so here, this is like we use the OPA policies, that is Open Policy Agent, to like do the rule matching and execute whether the event was as per the definition of the organization or not. So what we do, we these are the rules that we run today. Basically, a role was attached or detached in your cloud account that we will flag. And let's suppose a schema was altered on a table under an audit that was not supposed to be, that these things we will flag on the left side. And the baseline we are building, this comes to the behavioral part, that let's suppose there is a service account that has never touched a table before, but like it touched today. So we will flag that out. This is what we are building right now. And it also learns per the tenant, because normal is not portable. So we do not block any query. And this is the choice rather than gap, I would say it again. Standing in the query path means we can add latency, and we can take a database down as well. So no bank will accept that trade for the feature, right? So preventing for us is closing the exposure before anyone uses it. A bucket open to the world. Okay. A service account with delete rights on a table of identifiers. Records sitting on the wrong country. We find those and hand them to you with the fix. Those are the alerts and the flags that we raise. Let's go to the next slide. Yeah. So again, alert is only useful, right? Where your analyst already are. It's not like we are asking you to have another sort of integration for getting our alerts. So we do support like Jira, email, Slack, or even in your own SIM. We deliver the alerts there. It's not like we will say that you will have to add these in your stack to get our alert. And then each alert carries the context, as I mentioned, not just the event. So it will contain that when it arrived, who could reach it, and where it got performed, and what it did. Okay, and obviously we do the deduplication. It's not like you will receive a single alert only for a single performed action if it is as per the flag. Our pipeline do promise at least one delivery, but we do the deduplication on our side to make your job easier. So we also hand you the exposure and then the fix rather than acting on the system without asking. Okay, so that is a deliberate position, not a missing feature. We don't do auto remediation, but we do provide the things that, okay, you can do this to have these things fixed. So let's move to the next slide. Yeah. So so one database, two producers, one record, right? So now I'll just set more context here. Like, let's suppose knowing a table, right, that holds identifiers does not tell you it is being abused. And 10,000 access events tell you nothing until you know which tables mattered there, right? So that's why here comes the correlation that we do. So what do the two halves give you together? That is what we are solving here. Okay, so let's suppose there is a table containing the Aadhaar, and we got the events that were being performed on that. That is much more riskier compared to a random table that is being bombarded with some events. That is also riskier, but if you do the comparison, then you will put the Aadhaar one on the top, right? So again, that is what it is. What is in it? Like sensitive data types. What do they contain? That is what we are getting through our DSPM pipeline. That's why we call it the intelligence layer. And then who could reach it? This is what we get from the permissions, existing permissions that a person should have. That this is what also we show in the access graph. And who touched it? This is what you will get from the activity monitoring that we are doing after the normalizations as well. Now, so if we talk about like agent discovery, right? So it records, its records were rekeyed onto a shared asset ID, you can say it. Okay. So both pipeline describe you the same object rather than two things that look similar. One thing we deliberately did not merge is authentication. A dedicated agent token and its own signing key validated offline by the collector. So if you see our agent is sitting on the data plane, when we get the event, we do check it like whether that event is like from a required tenant or not. We do resolve the tenancy as well, so that we could understand that who is the one who is performing the event and from which tenant we are getting the event, and is it the tenant that is registered or not, or is it the hacker that doing it. So that is all this is about. So I think prevention is closing the door, not slamming it, right? So I would like to hand over to Shubham from here. Yeah, thank you.
All right. Thank you so much, for explaining in detail in regards to like how we have actually thought about approaching DAM and DDR as a problem. I would like to summarize. So, when we are building Matters, we're trying to build Matters from a perspective that it can be a security engineer that understands your infrastructure, resides in your infrastructure, and works as a security engineer like any other security engineer within your organization. So from a coverage standpoint, right, we support endpoint. We have first class endpoint support, and the classification that happens for endpoint also happens on premises. We support on-prem infra. We have a suite of self-hosted DBs that we support. We support on-prem infra like SMB shares. For cloud, we have support for three major cloud providers, that is AWS, GCP, and Azure. And we are also expanding our SaaS support. We currently have O365, Google Workspace, Gmail, and Slack. So with context around all the security events and DSPM understanding of where your sensitive data lies across your services and endpoint and your cloud resources, right? Matters is able to have a very good idea about the security posture and also a real-time event monitoring in regards to how your data is actually moving within your organization, and not just any data, but more to the sensitive data. We have a co-pilot layer, that's our AI assistant, that basically tries to, or I would rather say behaves in a way that a standard security engineer would behave, in terms of flagging issues, highlighting issues, at places, trying to perform remediation, like how a senior security engineer would do. So that is the whole perspective and the philosophy with which we are trying to build Matters AI. And I then hand it over to Yash to talk about the tech stack that we are using and how what infra elements we're using to actually solve these problems.
Thanks, Shubham. So this is basically a high level snapshot of all the tech stack that we have been using to build this entire platform. So we have services majorly written in Go, Java, Python, and we are expanding few things in Rust as well that needs to go on-prem and needs to run very lightweight, right? And our deployment model, as we already talked about, is through Kubernetes, Argo CD, Helm, K3s, and our observability stack is built on top of open telemetry. And the beautiful thing about open telemetry is that it decouples us from what server we are using at our side, right? We can replace it anytime without even affecting the service running on the customer's data plane. And for transport, we immediately have RabbitMQ as our cross-plane communication link, and we are expanding to gRPC, wherein we have real-time streaming events. ClickHouse is our event store that we get from our DDR and DAM ingestions. MongoDB and Postgres is our primary DB for our infrastructure, and for this rules and rule evaluation, we use OPA policies and rule engines as well. And for classification, we also incorporate third-party validations such as lunch check for credit card or and these things. For all the engineers out there, if you are curious about any one of these, you can have a look at this slide, and anytime you are curious, you can reach out to us, and we will be happy to have a conversation with you guys.
Or also read our blog posts that we publish on our
Ah,
Matters website.
Definitely.
Yeah, so I think we would like to conclude with that. We would like to open for questions in case there is any questions. Let me open up the Q&A section.
I think there might be in some chat as well. Let us also go through that.
Right. All right. Okay, so I think Vishal has a question regarding, can we discover classified data residing on endpoint machine or local drives? I think yes, you would be the right person to take this question.
Yeah, sure. So, yeah, Vishal, definitely. As we already talked about in the presentation as well. So, our endpoint classification is a two-layered architecture, and it all depends on how the customer wants their data to be scanned, right? So, if you want a more enriched classification, we suggest or we prefer customers opt in for the server based classification, wherein our engine gets deployed in your infra, and the endpoint agents data is scanned by that engine, right? And a second tier to it is local data scanning, wherein your data can be classified locally on the endpoint itself with a bounded resource provisioning, so that it does not affect the other processes that are running on the system, right? And both of these architectures are live for our customers and have been very well battle tested as well.
Thank you so much, Yash. I think there is a question from Renuka Yadav. How do you identify false positives during alerting? Vaibhav?
Yeah, I'll take that. So, great question, Redwa. So, basically, most false positives come from not knowing what normal look like. Okay. So, what we do, we first observe the alert, basically the behavior. यहाँ पे, ठीक है? So, who queries what, from where they are querying, and at what time. That is the baseline that is gonna kill the noise. So, then let's suppose there is a bulk nightly ETL job that is running that might be scary as well, right? So we do identify all of those things, and then we set the baseline. Then when we on top of that we are already building, that is what on the Yuba side is behavioral model, but on the static rule engine we have the feedback mechanism to take, like basically what is the true positives and what are the false positives, and it also minimizes based on the Rego code that we provide the modification and flexibility there. So as per the alert volume, it can be modified to reduce the alert volume too. So the baseline here is setting the baseline itself for the UVA mechanism to be built so that the noisy alerts can be cancelled easily.
Right. And I think to add to that, Vaibhav, I think you already mentioned this. our DDR and DAM works hand in hand with DSPM, right? So
Yeah.
we already know where the sensitive data is, and if something fishy is happening on that sensitive database or a table that is containing sensitive information within the client's infra,
Yes.
then I think we have algorithms that can attach severity to the alerts
Mhm.
that makes the alert more intuitive.
Yeah, that helps us getting the CVRT too. Yeah, true.
All right, thank you so much, Vaibhav. Any more questions? You can just post your questions on chat. We'd love to answer any questions that you might have. Okay, so I think Yash has shared our blog link. These blogs are really insightful. We keep on sharing what we are building, how we are building, what challenges we are facing. So a lot of insightful things for any engineers who would have joined this webinar. Tony, are we missing out on any questions?
I don't see any in the Q&A section.
No, team. We are good to go.
So I think we would conclude with that. I would very deeply like to thank everyone who has taken out time to join this session. We are at Matters tackling these problems, and we are trying to solve them very fundamentally with first principle thinking. And we are in the hope that we solve these problem of building an AI security engineer in a way that is really useful and helpful to the customers that we are working with. So we'll keep on sharing our insights on our blog, and we'll keep on having webinars like this and keep you posted. Feel free to reach out to any one of us on LinkedIn. Okay, I think we have a question. Okay, so the question is, let's say we discovered data and found out it's sensitive. So do we have the option to remediate or revoke permissions to that data? Yes, so we do have this option, Vishal. So predominantly we are having this option in case of SaaS because say a setup like O365 or Gmail, right, wherein your org users are basically sharing a file that contains sensitive information publicly that they shouldn't do. And if you say we are raising exposures along those, so Matters internally has an mechanism that allows you to remediate issues like this. And this mechanism of remediation also is very well vetted and comes via really well audited pipeline. So we will have approval steps. So in case a security engineer wants to remediate a certain exposure that has been flagged by Matters, it needs approval. So you can have different tier of users on Matters. You can have an admin user, you can have an analyst added. So analyst can raise a request, and then if the admin approves it, the remediation would take place. Any other questions? Vishal, I hope that answers your question.
Yeah, Vishal says thanks.
All right, cool. So we would like to conclude with that. Thank you so much for joining. You can reach out to any one of us. We're all very approachable. Just drop us a LinkedIn message. We would love to have a chat, and then yeah, we would like to conclude with that. Thank you so much.
Thank you
Thank
so much,
you
everyone, for
so
joining.
much.
Thank you so much, Shubham.